Hello and welcome to Itron Utility Week. We're here doing a lot of interviews, but also I felt that we need to capture some of these live demos that we've put together. And let me introduce Brandon here, who's going to take us through the gas demo. You can also see the water and electricity demo as part of the footage that we've captured here as well. But I know very little about this demo, so I'm going to hand over to you, Brandon, and if you can take us through it, and let's see how all of this works and joins together.
Excellent. So the key message here is our gas solution is all part of the OpenWay Riva messaging, and comes up all these sensors now, moving beyond the gas metering, which is the key message, is now incorporating pressure data, temperature data. You'll see cathodic protection, which allows us to sense corrosion in pipelines and that, as well as adding things like methane and gas quality. And so the story, moving beyond metering for us, starts first and foremost with system integrity. And things that we're now able to measure and bring back through the OpenWay Riva network are things like pressure and temperature and gas quality. All key components for a gas network in being able to ensure the integrity of their system works. And so what you're seeing here on the screen is a graph of temperature data on the top and pressure data down below.
And I know you guys have ratcheted up for demo purposes, but this is polling at what, 15-second intervals or something like that?
Yeah, what you're going to see here is it's polling at about 10-second intervals.
Right.
That's correct. And so, to your point, that's one of the key challenges for our gas and water industry is battery powered. Right? And the technology that now is evolved is being able to take these microprocessors and memory and be able to run those on battery power for many, many years.
Right.
Gas communication modules typically run for 20 years. If you're sampling at this high a data rate, it may be closer to 5, right? So these are the things that we optimize, in the gas system.
And then you have to take into account to say, okay, for a demo purpose, you'd roll it up, but in the field you might say, hey, this one will need this sort of, but the point is that it's adjustable, right?
It is adjustable, it's very configurable,
right.
Exactly, and that's the power of the system, is there could be use cases that still require 10-second data.
Right.
That's fine. If it's a use case for safety or pipeline integrity, that may be very pertinent, and the utility may be fine with a 2-year device.
And how sort of new is it that you've got here? You've got pressure, temperature, and then you've got the gas quality, right? So gas quality, how much hydrogen, how much methane, and so on, and that's very important because people pay on that, don't they?
That's correct. Right. That's correct. So on the gas quality side, we've got one of our customers up in Canada, for instance. One of their key differences in Canada is they're bringing in gas from, I think they've got 4,000 wells, independent wells that they have to bring in. And the challenge for them operationally is they have to go out to visit about 1,200 of those every 2 to 4 weeks. A lot of manpower to go take a sample of gas, take it back to their lab, and actually run that through a gas chromatograph to determine how much heat content is in that gas, so that they now pay those suppliers for the gas that they're putting onto their network. What we're looking to do with this sensor is automate that so they don't have to go out into the field and actually collect that data every couple of weeks. They can do it automatically every day. And
then you only send people out when something's actually going wrong, and so on. So you've got all of those savings as well. So what's going on in the sort of next panel, if you think we're done with what we've got here?
So this is operational, or should say system integrity. And just as for instance, if you want to get a quick live demo, we can bleed the pressure off on this pipe, as if there was a leak, for instance. And when that drops below 5 pounds, here, and you can see the pressure drop, the system will then go into an alarm. And what this simulates is if there's been a rupture in the pipe, from a safety perspective, the utility now gets an alarm and indicates they need to dispatch a crew in order to solve the pressure situation.
And I know you haven't done this here, but I would imagine, and I know it isn't easy, but this is probably mapped over some sort of geolocation as well, so you know exactly where this event has happened.
Yes, exactly what pipe it's on, all of those things, correct. And the key thing here is the communication system that we use all plays within Riva.
Right.
This happens to be, we call it a sensing gateway, allows us to bring in a variety of transducers. In this case, it's pressure, temperature. We also are bringing a cathodic protection device, which we'll talk about in just a moment. This particular instance is cellular. Be able to push over the cellular network, which is another part of the Riva story, being able to bring in not only our adaptive communications technology, but cellular is part of the solution.
So the cellular thing being, going back to the story in Canada, I would imagine these wells aren't conveniently located, right?
Exactly.
So you can then get all this data back through a cellular network and so on.
Exactly, and that's the nice part about these complementary technologies. And cellular can be used either as a hole filling technology, where the network coverage is spotty, or to your point, out in the rural areas where you've got pipelines, as you know, that go across the country,
yes.
right? And it's not convenient to put network infrastructure over all of that if it's only picking up a couple of points. That's where cellular comes in very handy, very economically, and is a good solution.
And then we're moving on here, where we're looking at more of what's happening at distribution end, right?
That's correct.
Yeah.
So this is out more from a gas safety. One of the biggest things gas customers worry about is safely delivering gas to the end consumers. Leaks are one of the things they monitor for and make sure they're delivering gas without incident. That's a big challenge.
So we can see here that you've got gas flowing. So this is the gas that's coming into my house.
That's correct.
Effectively. And then over here you've got the meter that is at the end point. Now this meter is not now just about measuring volume, so you can bill me. It's also gives you a safety component.
That's right. So in this particular case, this is a methane sensing device,
right,
and could be used on your home. A lot of the applications could be in a high consequence area, where it could be a hospital, right, or a stadium where you're concerned about, could be terrorism, or could just be a natural incident that happens where there's a leak that occurs.
Well, things
right?
leak, right?
That's right.
There's some, so I'm looking forward to this because I get to use this thing. Right?
That's correct.
Can I do this now?
You can do that now.
Okay.
So what we're simulating here is a gas leak. So if you.
So if I'm going to start this off, hang on. I'm getting a little smell. Yeah, that's going. So we're simulating. Am I putting it in the right place?
Yes, you're in the right place. So hold it for probably 5-6 seconds, and what you'll see here is that should be enough.
Okay.
It samples about every 30 seconds here.
Yeah.
And when there's enough methane in that sensor detects, it sends
Locks
up
it down.
an alarm to the head end. You can see here on the graph, what we do is we've got set points within the device for what's called the lower explosion limit, and that's at 10%. And when that crosses 10%, as you can see, we start sampling more frequently, knowing that there's a potential hazard on site. That's step one. Where the Riva technology is really powerful is it now allows peer-to-peer communication.
Right.
I think what's cool about that is this methane sensor can now communicate to a disconnect service.
Right.
So if your house or this location has a disconnect valve, that communication can be sent. You can disconnect service and position for a much safer environment and mitigate the leak.
So I always like to throw up probably out there scenarios to do the thing. So you could have a residential area, a lot of houses. A lot of them are detecting a leak. Well, I mean, I know it probably won't happen, but imagine it did. A lot of them happen. You actually shut off at the distribution end. You say, okay, something's going on. We don't know what,
right,
but there are way too many sort of leak detection or methane sense events, and that distributed knowledge is the new thing.
That's right.
Yeah.
That is the new thing. And so you've got the ability, based on the utilities business case, how many of these sensors do you want to put out, right? And to your point, is this shut off, further upstream? It may turn off several houses, but it saves a potential event from occurring, right? So a lot of power in that. Another use case, just as we've been developing this technology on the East Coast, we get hurricanes that come through. The other angle is not just sensing methane, is floods. What happens in a flood?
Right.
The appliances, what we saw with Hurricane Sandy that came through years ago was the floodwaters came in, the appliances actually started floating away in the house, broke the gas line, and the house is filled with gas, and an incident can occur, right? So now we've got the ability to put flood sensors in an area and disconnect service.
So you've got a platform that can take all these sensors, and now you're designing for use cases. You're saying, right, okay, well here we need flood sensors because that makes sense, and here we need sort of methane sensors and so on. And then, like you said, it's up to the utility about how many sensors you can invest.
That's
right. You can go crazy and put a sensor everywhere.
Exactly.
But that's probably doesn't make business sense.
True.
Right.
True.
Okay.
True. And I think that's the key thing: is where is the value? How much risk is it that they're trying to mitigate? That's all built into the business case that helps justify it.
And then what have we got here?
So the next panel here, what we're discussing is really operational efficiency. And this has been our core business for years. This here is our gas module, our Riva gas module, called the 500G. We're actually, from a presence in the industry, most of that's been our mobile play for years.
Right.
We're actually crossing our 60 millionth device here in December that we've delivered to the industry. Why is that powerful? We're now in a state where we can move these folks from mobile to the network, the amount of interval data that they can bring back and start seeing additional value for the consumers, where the consumer can see every day how much they've used through web portals. They can also get alerts if they've got abnormal behavior going on, in case they may have a leak in their house or are using more than they would expect, right? Helps the end consumer tie directly into the utility much more real time. So that's been our core business. We're still growing that business. But now, what else can we automate? How can we help the utility with their operations? And here's a particular use case. This is what we call our cathodic protection monitoring. Pipes, a lot of the high pressure lines that run across North America and the rest of the world are metal. They corrode over time. And so the utility has to go out periodically, typically at least once a year, sometimes quarterly, to measure voltage on the pipe. And because they typically impress a current on there, looking for a voltage drop, which is indicative of corrosion. And so what we've done...
the old I squared R equation.
Yes,
right?
there you go.
Yeah,
the whole Ohm's law, exactly.
Yeah.
And so what we've enabled here is actually automating that voltage reading. And instead of somebody driving around in a truck, monitoring that pipeline and making those measurements, we can now bring that through the network. And what this is, and what we would show, it's a voltage monitor. And honestly, it takes time, often years, for things to corrode. And so what this is a very simple demo. If you want to turn the knob.
So this is effectively just a variable resistor,
exactly.
Right? Yeah. So I'm turning it up to max.
Yes, so you should see.
Yeah, I've got max here.
Yeah, you should see that voltage,
Oh, here we go.
Spike up immediately. Yeah. And what will end up happening is the device will push that communication up to the head end, and we'll know that in the software it's exceeded that upper limit.
Right.
And at this point in time, what a utility would start scheduling that pipeline
and this is an extreme scenario, but as we all know, corrosion is a very incremental thing. Yes. So I would imagine that you can then, I'm turning it down now, but at the utility side, you can start saying, oh, well, this is starting to creep up, and you can be a bit more preemptive rather than what we've just demoed is like a probably a failure, right?
Yes, exactly. Like you're spot on. Exactly. The corrosion is usually over time, so you're looking for a trend, right? And that's the beauty of this device. You're getting a daily read out of the system versus once a year. And so you can see things track over time from a trending, which allows you to do what? Capital planning and investment to actually replace that pipeline over time. In this particular case, as you mentioned, the system, since it is monitoring your cathodic protection, if there is a drastic change like that, you may have some construction going on in the area and you've damaged a pipeline, which also gives you an additional use case to be able to address, right? Yeah.
So all of this sensoring is just giving all this distributed intelligence. Let me ask you one question, because we ran through a similar demo with your colleague over at the water side. We've done the electricity side, and it's a big message of this event that everything's going into the OpenWay Riva platform, and I know that is like an early start, but can you see a vision where all of this is kind of colliding against each other? So that you've got sensors from the electric network, water network, because you do have integrated utilities who are doing all of that. There must be, in that use case, I'm not saying every utility is like, there must be some real economies of scale to have like an overarching platform where you've got one platform, not 5 or whatever. Yeah.
That's exactly the point. Is we've got some utilities, it's natural, right? It's a combo utility that's got electric, gas, and water. So using that one asset of the OpenWay Riva network makes a lot of economical sense versus having to put up a network for each application. And what we're seeing even in various regions is the actual utility commissions are saying, guys, the electric utility has already put up a network. Why aren't the gas and water utilities that sit underneath that territory using that same asset? And we're seeing that start to transpire. We've got a couple utilities already, Montana Dakota Utilities is providing readings for Bismarck Water. So we're starting to see that happen, and pressure from the public, if you will, to say,
and also the regulatory framework and everything like that was just like we're adding to the cost to serve effectively by having so many different networks.
Because the end payers for that gas or electricity are having to fund multiple networks. Why not use the same and leverage that asset? It's really being resourceful with what we've got.
And that's perfect. And on that note, we'll stop it. And thank you for watching. I hope these demos are bringing all of this technology to life. Thanks for your time. It's been great.
Yes.
And thank you as well for watching.